The remainder of my presentation is going to be trying to go into a little bit more about the detail of the simulation results. And for this study, we looked at 5 cities in the Middle East, simulating 1 kiloton attacks. And here are the cities on the map that we simulated. And so to develop this methodology, I had to use several different data sources and resources and some different simulators, such as the hotspot simulator program is from Lawrence Livermore National Laboratory, and the high split program is also very important, which is used for atmospheric transport modeling. And it can be used not just for radioactive material spread, but also just pollution or volcanic ash or the smoke from fires it's used for. And also it has been used for nuclear fallout, traveling over distances and depositing on the ground. So it's some nice and complicated program that I learned to use for this project. And using all these resources and spending an Oak Ridge National Laboratory, I want to mention for the population data. They have nice population data sets. And so using all these resources and spending several months, I developed a methodology to kind of get a basic idea of what casualties we might see in the Middle East. And the results of these simulations were understood in 3 parts. So there's the first, the lethality due to the structural damage, and 2, prompt casualties due to the direct effects of the nuclear blast, heat, and prompt radiation. So these effects are defined as occurring within 1 minute of the explosion, or about that time. And finally, nuclear fallout. And it turns out for a surface burst, nuclear fallout is very significant, as you will see later. The nuclear fallout can increase deaths due to the radiation that it emits onto the populace, and is greatly affected by the weather variations, and in some cases can travel hundreds of thousands of miles to affect millions of people in some way, even if it's just raising the cancer rates. It can possibly travel very far. So first, I have a few maps and some different graphics to show you to explain these facts, and I hope that I can explain them clearly because there's a lot going on in some of these pictures. So if you have any questions to clarify, please ask. So first, I looked at the structural damage, and this is of course important because there will be a wave of overpressure at first coming from the detonation, which will destroy buildings. And there will be lots of falling debris and glass flying, causing lacerations and lots of physical injuries that may kill people or injure them so that they cannot be mobile. And also, so to estimate this kind of simulation, what's really a complicated simulation of a nuclear blast in an urban area, I had to kind of estimate what kind of building damage is occurring at what distances. And this picture is here to basically give you some idea of how far the building damage due to the blast may extend for a 1 kiloton detonation. So about 4 kilometers away, this pink circle, you may get some glass windows breaking. And then the yellow circle, you will get some considerable building damage at about 1 kilometer away. And most of the deaths due to this analysis is significant because most of the deaths due to the blast will actually be caused by falling buildings and structural damage, as opposed to the actual pressure on the human body. The human body can actually withstand quite a large pressure relative to buildings, it turns out. So that's why this is important in the simulation.
By the way, let me interject. It seems kind of nutty, I suppose, to look at Tehran. But if you're pretty hard bitten, you'll remember that there was an article I encourage you to read about what the public's in the United States view is of how we might want to respond if an aircraft carrier in the Gulf that's ours was hit by some missile that was Iranian, and there's an overwhelming popularity to attack Tehran, and we have low yield nuclear weapons. So this is not. I mean, this is a little nutty, but it's not a totally inadmissible thing to ponder. Uh, I mean, it's certainly conceivable, and I can assure you, at some level, I gotta believe somebody somewhere in the Pentagon, has done similar analysis. Okay, I'm not sure this is the most probable thing. With any luck, I'm pretty sure it won't happen at all. But people think about this. This is not a lunatic scenario. Okay, all right, go ahead.
So, yeah, so I think that's my main point. Structural damage is really key when we're trying to estimate these things.